Radiation testing answers all the questions. In one of our previous clips, we learned how Geiger counters are incomplete on measuring radiation. Geiger counters can potentially measure false positive readings due to naturally occurring radioactive particles and even a red plastic cup. Geiger counters can be helpful, but the real answers are found when you want to measure the specific isotope and how much is present. If you want the real answers about radiation, long-term isotope monitoring needs to be done by private parties that are not influenced by the federal government. We need testing for the people, by the people. We should be monitoring food, soil, and water on a long-term basis. Radiation testing is done to discover the truth. Are starfish and mussels dying off due to radiation levels? What are the levels of strontium-90 in tuna bones? All this can be answered with your help. As stated earlier, I-131 is a tough isotope to test for since its half-life is only 8 days. But we can test for cesium-137. Cesium-137 uses a completely different method for measuring. The most widely known method is gamma spectroscopy using EPA 901.1M method. Mass gamma spectroscopy indicates that the entire wavelength of gamma rays are measured. Gamma rays are thousands to million times higher than the standard optical spectroscopy. The gamma ray spectrometer also determines the energies of gamma rays and photons emitted by the isotope. There are two types of detectors that are more commonly used. A CSI sodium scintillator detector, and the second, more commonly used, is the high-purity germanium detector. Scintillation detectors can also detect alpha and beta rays. Again, a Poisson distribution is used in the calculation to determine the overall amounts of radioactivity. In this case, the amount of energy emitted varies, and peak areas are calculated by the detector. Specific peaks can then be identified and based on their signature, and the amount of radioactive energy is calculated after subtracting the calibrated standard. Strontium-90 isotopes are separated using the latest analytical techniques. The first phase is using an ichrom separation technique, which is an extraction method. A column of resin is poured, and the liquid sample treated with acid moves through the column. The resin will help separate the materials due to size exclusion, resulting in separation of components. Other factors that affect the separation of the sample include specific resin, the particle size, the porosity of the resin, the sample loading, mobile phase velocity, and temperature. Once the basic separation has been completed, the next phase of analysis is performed. Gas flow proportional counting is the next analytical method that atomizes the sample into a gas and then separates via rate and pressure. This is controlled by using a separation column length. The sample has the level of beta particles measured. After correction for absorption between the source and the detector, as well as the source mount, backscatter, intrinsic beta efficiency, and multiple count factors, as well as self-absorption factors and dead time factors. Well, let's put it this way. In plain English, the amount of radiation is measured using a beta counter with several other analytical corrections to get the most accurate reading. The calculation of beta particles results from electron interactions satisfying the formula of the Poisson distribution. The exponential distribution has a memory-less property regardless of previous history. The probability of interaction over the next unit distance is the same as the probability over the distance of any other measured. In other words, factors leading up to this analysis being run should be universal and independent of previous analysis. Thus, the exponential attenuation of beta particles is a measurement limited by the finite range of electrons and is specific for a certain radionucleotide. The readings are then converted using an efficiency estimator calculator specific for strontium-90, which is known as a counter. The measurements are compared to known calibrations, and the total amount of isotope can then be determined. Analytical testing is not cheap. We need funds to operate. What is more valuable? Working at an issue based on feelings, or spending some money and working with the truth, the facts? I'm not asking for a donation. I'm asking for you to contribute towards analyzing a sample that you want to know more about. You pick the sample, not me. Let's all be part of the group that is committed towards finding the real solutions. People can spend a great deal of time and emotion or spend some money and get the truth. It's your choice. Let's all work towards creating that database that is independent of federal influence. You can learn more about us at radcures.com, and please sign our Cancer Cures petition. Thank you.